So we have a 4 kilogram block being pushed along the ceiling with this constant force of 85 Newton at an angle of 55 degrees. This block accelerates to the right, so we have an acceleration, which tells us that there must be a net force. If the acceleration's to the right, which way is the net force going to be? To the right, because net force and acceleration are always together. And we know that this acceleration is 6 meters per second squared. What we're trying to find is the coefficient of friction between the block and the ceiling. So if this is the block right here, what we're trying to solve for is the coefficient of friction between the block and the ceiling. So this whole problem begins with a free body diagram. There's 4 forces total on this block. So the 4 forces total, we'll start with the 85 Newton force. 85 newtons is directed this way. It's at a 55 degree angle, so make sure you show your angle. mg is always straight down. Normal force. Now typically we've said normal force points up, and why is that? Well, usually, which way does the force of a surface act? Up, right? But here, if you're pushing the block into the ceiling, the normal force is going to point down and perpendicular to the ceiling. So normal force is like that. And then the final force, there's a force of friction. If this block is moving to the right, then friction must be to the left. And friction equals coefficient times normal force. And we're trying to solve for this coefficient. Okay, sign convention is like this. To the right plus, to the left minus, up plus, down minus. So the next thing we do after the free body diagram is done is we're going to sum the forces. So we're going to sum forces in the x direction, and we're going to sum forces in the y direction. The sum of the forces, when you're done doing the sum of the forces, what is it always equal to? MA. Where that's an x acceleration, and that's a y acceleration. Okay, real quick though, which way is our acceleration here? The block accelerates to the right. Is that x or y? X. Okay. What's going to be the y acceleration? Is this block accelerating in the y? No. So in our sum of the forces, in the sum of the forces, this y acceleration is going to be crossed to 0 because there is no y acceleration. Okay, one thing we're going to have to do before we sum the forces, the 85 Newton force, we got to break that into components, don't we? 85 Newton force, we're going to break this into x component and y component like that. So the x component is going to be cosine 55 times 85. The y component is sine 55 times 85. So now we're ready to sum the forces. How many forces do we have in the x direction? There are 1, 2 in the x. So paying attention to sign convention, it's going to look like this. Summing forces in the x, we're going to have cosine 55 times 85, then minus friction, and I'm going to put friction in as this, as mu Fn, because that's the equation for friction, mu Fn. This is the sum of the forces. What does the sum of the forces always equal? Ma. So we just wrote a very useful equation that'll help us solve the problem. Okay, turning to the y direction. How many forces are acting in the y direction? We have 1, 2, 3. There's 3 forces in the y. So here's what this looks like. So this guy points up, so we'll make him positive. So it's going to be sine 55 times 85, right? That's this guy right here. Then minus mg. Why did I make mg minus? It points down. And then minus normal force, because that points down. Now this is the sum of the forces for the y direction. What does the sum of the forces always equal? Ma, where that's a y acceleration. But what did we say the y acceleration will be? 0, because the acceleration is only in the x. So this is going to be equal to 0. Now, the rest of this problem is algebra. We know m. M is 4. Gravity is 9.8, right? So what can we can take this equation here and solve it for what? Normal force. And when you do that, normal force comes out as 30.4. That's just algebra. Okay? Take this normal force, plug it in here, right? And then once you do that, we can solve for mu. Make some room. Okay, so now, do we know what m is? Yes, it's 4. Do we know what a is? Yes, it's 6. If you look at this equation right here, we have everything except for what? Mu. Take this equation, do the algebra, solve for the coefficient. If you punch the numbers in correctly, you get a coefficient equal to 0.81. And that's the answer.